Hi everyone! In this video, I'm going to demonstrate how IBM Cloud Pak for Data makes the process of accessing and collecting all of your data simple and streamlined. Using AI and machine learning algorithms to make impactful predictions for your business starts with having access to the data across your enterprise. It's simple. Good data, and a lot of it, means more value from AI and machine learning. So let's get started. I'm going to take on the role of a data engineer in a scenario where she has been tasked with combining remote data on cancer patients' gene expression with local data that holds the cancer type identifiers for these patients in order to analyze trends in the gene expression by cancer type. The gene expression data is in a remote DB2 on Cloud database that we will have to connect to. The cancer identifier data is on the data engineer's local system and will be uploaded to Cloud Pak for Data. Starting from the login page on the Cloud Pak for Data portal, let's get started. This is your home page. You navigate Cloud Pak for Data from the hamburger bun menu in the upper left-hand corner. You'll find Data Virtualization under the Collect category. This is what will allow us to connect to the DB2 database. We navigate to Data Sources from the drop-down menu and can see the different data sources that have already been virtualized from. We need to add a data source, and we also need to add a new connection. This is where we create and define our new connection. The Connection Type drop-down menu is an extensive list of databases that you can connect to. Don't be bummed if you don't see the database you need. IBM offers connections to various data sources out of the box on the platform, but you also have the option to upload custom JDBC drivers to connect to any data source that you may have. The credential prompts pop up once you've chosen the connection type, so we're going to add the DB2 credentials now. Once we've entered all the necessary credentials, we have the option to test the connection to verify that all the information was entered correctly. Everything was entered correctly, and we can add the new connection. Navigating back to data sources, we should now be able to see the connection that we just made. The next step is to virtualize the gene expression table from the new data source. This is where you shop for data to virtualize. On the left of the screen are all the different types of data sources that we're able to virtualize from at the moment. The list keeps growing. We're looking to virtualize the gene expression table. And using the search bar, finding it is simple. You can also narrow down your search by database and type of data that you're looking for. And there's the dataset from the DB2 database. We can select it and add it to our cart. In the cart, you can rename the dataset. You can assign it to a data request, a project, or My Virtualized Data. We'll send it to My Virtualized Data, and we can go ahead and virtualize our dataset. It's time to check the quality of the data. Data Discovery will show us a quality report and description of the cancer gene expression data. To navigate there, you go to Organize, Curate, then Data Discovery. There are two options for how to perform a discovery: a quick scan of the first 5,000 records, or a thorough analysis of the complete metadata, which is what we're going to do. So you can run a discovery on multiple data sets at once. You can either type in the root if you know it, or you can search for your data sets like I am now. There are a lot of options you can specify when running a discovery. We want to analyze the columns for data class and see if the data quality is good or bad. You can also choose to assign business terms from the catalog. Down here we can specify if we want data sampling in the automated discovery. You can choose the first, X number of rows, or you can choose a variety of different rows for every set number of rows, or you can use a random sampling. The results of this discovery go into what we call a workspace. I created a new workspace for our discovery job. It takes some time for the discovery to run, and you can keep an eye on its progress here. You don't have to stay on this page though. You can virtualize more data or work in a project or other parts of Cloud Pak for Data while this job is running. Once you see that it's finished, you can look at the results in the workspace. This dashboard with quality metrics is a great place to start. It displays some quick results of all the sets you ran the discovery on, even though we only used one in this example. Some of the things we can see here are how the data compared to any quality threshold views that were set, relationship analysis, and also how many data classes it has. For a more granular look at the dataset, you can click on it from the left side of your screen. This is where we'll find a thorough analysis of our cancer gene expression dataset. If we had chosen to assign business terms, you find the results from that under this Columns tab. On the left-hand side, you can navigate all the columns in the dataset. You can even click on them to get more information on it. We didn't assign any terms to our mostly numeric dataset, but it did suggest a few. The Governance tab allows you to make any changes to the assigned terms that you might need to do, and you can also do things like adjust data quality rules and review the data classes. Data discovery is a great solution for promoting trust and transparency in your data, so the users can be confident in the accuracy of their analyses and predictions. Now that we are confident in our data, we need to put it in a project and load the cancer type data from our local system to the same project. To add an asset to your project, you use the Add to Project button on the top right. Choose Data Asset, and now under the Catalog heading, we can search for our gene expression dataset. We will now upload our cancer label dataset from our local system. Under the Load heading, we can browse our files. We're going to create a joined view of the data. This joined view will allow us to easily create visualizations of the variation in how specific genes are expressed in patients with different types of cancer. To do this, we select one of the tables. That opens up the dataset and allows you to perform transformations. Now that it's loaded, we'll click the Refine button on the upper right corner. On this page, you can code your own operations to cleanse and shape your data, or you can use the predefined operations. For clarity's sake, I'm going to rename column 0 to Sample ID. We'll now create the join view from the list of predefined operations. We can specify a left, right, or internal join, and then we need to add the labels dataset. In the next step, we'll create the join key, and this is where renaming column 0 to sample ID is helpful. So we're going to join on sample ID on gene expression and column 1 on the labels table. On the left, you can see the columns in the resulting dataset, and you can select or deselect any that you wish. At the bottom is column 2 from the labels dataset. Here is our new joined table with sample ID, and then if we scroll all the way to the right, we'll see column 2 with the cancer type labels. I'll go ahead and give this column a more descriptive name as well. Directly to the right of column 2 is a panel that lists all the refinery steps that have been performed on this dataset. Go ahead and save our new joined table. Let's take a look at the details of this new joined view. Go to Edit under Details, and you can see that the refinery flow is going to be in Demo 1, and we can change the name and enter a description if you want. And the actual data asset, the new joined view, is going to be in the Data Asset heading in Demo 1, and we can also change the name, add a description here. We've just gone through the steps it takes to connect to a remote DB2 database, virtualize a dataset from the database, run a discovery on it to assess the quality of the data, and then create a joined view using that dataset and data from a local system using IBM Cloud Pak for data. I hope you found this video helpful. I'll be posting more videos like this, so subscribe to stay updated.